Hey guys, welcome back to a new video. In this video I will show you how you can use Ktor client-side. Many people don't know that's actually possible, but yes, Ktor is not only a backend framework with Kotlin, no, it is also a client. So a network client such as OKHTTP, and we can use Ktor to make network requests, HTTP requests, to an API to get the response. And now you might wonder, why should you actually choose Ktor and not OKHTTP in combination with Retrofit, which is a really good combination. Retrofit makes that stuff really simple. However, KMM, Kotlin Multi-Platform Mobile, is becoming more and more a thing, so we can make iOS and Android apps with Kotlin. At least we can share a very big part of our code. And in KMM we have to use Kotlin libraries if we want to share these across Android and iOS. And OKHTTP and Retrofit are Java and Android libraries, so we could only use that for KMM for the Android side, but we couldn't share that logic that also the iOS side makes use of Retrofit. And that is why Ktor is a really good alternative to Retrofit to use for KMM projects, because we can make network requests with a pure Kotlin library, which also works really well. Now, if you don't use KMM, we also don't use it here, it still makes sense to take a look at Ktor, because you might like it more than OKHTTP and Retrofit to make your network requests. And especially if you watch some of my Ktor courses and you build backends in Ktor, then it also makes sense to take a look at this client, because it's built very similar as the server side. I mean, there will be some mechanisms you will face that you already know from Ktor server side, and these will just work together really well. So first of all, let's add the dependencies, and I will go through these to explain what they actually do. In our build.gradle app file, I will paste this. So quite some dependencies. Let's go through these. So we have our Ktor specific dependencies here, which all make use of the current Ktor version. So Ktor-Client core, just the core functionality, I think that's clear. Android specific functionality, because we can also use the Ktor-Client, as I said, for iOS, for example. Then we would need an iOS dependency here. We have the Ktor-Client serialization. That will be important to serialize our data. So if we want to post JSON data to an API or get JSON data from a response into a data class in Kotlin, then we will use the Kotlin X serialization plugin to actually serialize and deserialize that. And because I just want to show you an additional dependency here, I included the logging dependency. That's not needed to make the actual calls or get the responses, but it will log everything the client actually does. That's really helpful actually to debug your client, your network requests. It will always print the whole request and responses in the console, so that you can easily debug that and see where maybe something is going wrong. And that's also just a dependency here that's needed for logging. Then, as I said, we will use Kotlin X serialization to serialize the data. In Retrofit, we often use JSON or Jackson or Marshy, but those are also just Java libraries that we don't want to use in KMM. So I just show you the real KMM way here. So we will also just use a serialization library that is fully written in Kotlin, which is Kotlin X serialization. For that serialization library, we also need to apply a plugin up here, which is this. Of course, you can find all these dependencies and plugins down here on my GitHub repository. Just check the description. And one last thing we need to paste is to actually find this plugin. We need something in our build.gradle project file, and that is just this class path here with our Kotlin version. Then we can click Synchronize Now, close these two Gradle tabs, and actually jump into coding. And I will show you how I would now structure creating such a Ktor client to make network requests in a quite clean way. So first of all, this will be the API we use here. Not a real API, just a placeholder API that is used for testing. We are not working on a real project here. I just want to show you how to use Ktor client side. And maybe if you like this video, I will also soon show you how to use that in a project. That's just a placeholder API you can use. It comes with all different HTTP methods here. We can post, we can get, we can put, patch, delete. And we will just make sure, we will make use of this posts endpoint here, which will just deliver us with 100 posts, which is just sample data, just lorem ipsum, I think. Yeah, similar. So that's the JSON response we get. That's just one post with a title and a body and some IDs in a list. And that endpoint will also have a post method, so we can actually create new posts, just to show you how that also works with Ktor-Client. So remember that URL, jsonplaceholder.typicode.com. You will also find that down here in this description. So now we can actually jump into coding. First of all, I will create a package here called data.remote, and in that remote package I will create another package called DTO, data transfer object. So just the data classes that represent what we actually get from our API. So let's create that. You will see what that does. We can create a new Kotlin class of file in here, and I will name this post response. So that will be the response we get from the API when we create a post. That will be a data class. It will contain the body, so we have to name it the same way as in our API. Just these body, title, ID, and user ID here. So that will be one data class. Then val title, val ID is an integer here, and val user ID. And it's really just random data here. And if you haven't used the Kotlin serialization plugin before, when we use that, we also need to annotate the classes we want to serialize in the end with @serializable. So that way the Kotlin plugin actually knows, hey, that's a class we want to serialize. Now we want to do the same for the post request, which will be the same, and it just won't contain, I think, an ID or user ID. I think just the ID. So when we actually create a post with that API, then it will respond just with the post we created, and it will give it an ID. So it won't actually do anything server side or so, but it will just simulate a post request. So we can in the end just take this post response, copy paste it, and call it post request, and just remove the ID, because the ID comes from the server in the response. The next step is to actually create our API. So we need to define which different functions we have for API that we need to access the endpoints. In Retrofit, we just created an interface for that. We wrote some annotations like a GET request. We specified the URL. We specified some query parameters also with annotations. And Retrofit did the rest for us. In Ktor, we don't have that annotation processing. Instead, we need to kind of define our own interface for that, which isn't really much harder to do. So I will show you how to do that. We go to remote, new Kotlin class of file, and well, the naming is a little bit up to you. You can name it like posts API, you can name it posts service, which is a common way of calling these API services. That's how I will do it. And we'll create an interface here. It's not mandatory to create an interface. We could also directly create the implementation. But because I want to show you a good structure here, that is how I would usually do that in my projects. It just allows you to more easily test your API, because then you can create different variations of that post service. So the step in this interface is really the same as if we would create an API with a Retrofit. We just define the functions we have, and we just leave out the annotations. What do we actually have? On the one hand, we have a get function to get the list of posts, and on the other hand, we have a post function, so to create a post. Let's create these two functions. Those will be suspend functions. The Ktor-Client does everything with coroutines. I mean, it's a pure Kotlin library. That isn't a surprise that it uses coroutines. I'll call this get posts, and it will return a list of post response. And then we do the same for our create post function. That will now take the post request. That is the data we serialize to JSON and send to the server, and then get the response that this function will return, post response. It could be null in case something goes wrong, so we make it nullable. Now that's already it for the interface. You can see it's simpler than a Retrofit interface, because we don't need these annotations. Instead, for like the URL, maybe some headers, maybe some body content, we actually specify that in the actual implementation of that interface, which we didn't need to do with Retrofit. With Ktor, we do need to create an implementation of that interface. So we're going to go to remote, new Kotlin class or file, and we call that post service implementation. That will be a normal class, and it will implement our post service interface. Then you will see we need to implement our two functions. We can press Ctrl-I, Ctrl-A, and enter to do that. And now here we actually need to make the actual network call using our Ktor-Client. Well, where do we get that from? In the service we just injected in the constructor. So just private val client is of type HTTP client. You can see that comes from IO Ktor-Client. That is what you want to pick. And that will be the object we make our network calls with. So then for get posts, what do we do? It's really simple. You will see how that works. We just return client.get. We can use this lambda way of writing that. And here we just have a normal builder in which we can specify some more data about that GET request, such as the URL, for example. That's necessary here, but that is already it. We don't even need to know more about this request. You don't need to attach any headers, any body content, any query parameters. But if we would need to do that, we could do it in this lambda block. So we can specify the URL, the endpoint where this request should go to. So in Retrofit, we had this Retrofit builder in which we just specified a base URL. Here we don't have that. We can still do that, which I think is helpful. And for that, I will create another constant file here, which I will call HTTP routes. And in here, I'll just specify the base URL. Can be a private const val base URL, and that will just be https json placeholder.typicode.com. And then we can specify just one constant for each single endpoint we actually make use of. And in our case, that's just one, which is the post endpoint. And we can create that using our base URL /posts. Then we can just use that singleton here to get access to our endpoints. So in our post service implementation, we can then specify the URL to HTTP routes posts, and that's already it. So in case you would need a query parameter, you could simply do that with parameter, specify the key and the value. If you would have path parameters, then you would directly do that here in the URL. So if you would like to, if you would like to have something like the post ID here, and you would then access, I don't know, a user or so, then you would need to manually create that URL and just replace that ID with whatever you want. But for query parameters, you could also just attach these to the URL, but there's also a function, as you can see, to do that. You see, it's super simple now to make a GET request with that. Just requires 2 lines of code. If you write it in one line, even only one line. For the create post function, we need some more lines, not that many, but it's also very simple. And something I actually forgot, and I also want to show you, if something goes wrong, we need more lines, then we want to just surround that with try and catch. But that's also the same with Retrofit. So if something goes wrong here, meaning the server responds with a response code that does not start with a 2, because the response codes that start with a 2 usually mean everything went well. If it does not start with a 2, like the 3xx, 4xx, and 5xx, then something went wrong. And for each of these cases, Ktor will throw an exception. So on the one hand, we have a redirect response exception. Just to show you how you can actually distinguish these, you can also just catch a general exception and say, hey, something went wrong. So that redirect response exception will be thrown for 3xx responses. So when that is the response code, we can print like the error, and here we can say e.response status.description, for example, and then just return an empty list. And we can copy that catch block. I just want to show you the different responses, the different exceptions we have here. This would be client request exception, and these exception names even already tell you what they what they will be thrown for. So that will be thrown when there is some kind of redirect issue. That will be thrown when there is an issue in the client request. So when we, for example, post some data that is invalid, that the server doesn't know what to do with, then it will respond with a 4xx code. And then we have something for the 5xx code, which is server response exception. So that means the client request was okay, but still something server side went wrong. Maybe like the database crashed, or yeah, something unexpected happened, and the server just answers with, for example, internal server error. Then we would catch that here. And that's pretty much it. You can, of course, if you don't have internet connection or so, also have a general exception down here. And yeah, just also print that. Here we don't have that status description. We would just print the message. If you don't need that fine-grained control here, then you can also leave these away. But yeah, if you want to give your users maybe some kind of error message that is meaningful, you should catch different exceptions here. And if you also want to forward these error messages here to another layer of your architecture, then yeah, just check one of my architectural videos. There I use a resource class that I wrap around this response object, this return object. And with this resource class, we can just distinguish between success and error case and also attach corresponding data. But here for this simple tutorial, I just decided not to do that and just have a print line statement. Now for the create post function, we can actually just copy this whole thing here, because it's very similar. All that really changes is this piece of code here, because now we don't make a GET request, instead we make a POST request. This one here, you see we need to specify a type, which will be the response type. So what the server will respond with, which will just be POST response. And then here, yeah, we'll leave the URL as it is. We will call the same URL just with a POST request this time. Just two differences here for POST requests. On the one hand, we want to attach a body. We want to attach our POST request data that we want to post to the server. And on the other hand, we then need to assign the content type. So we need to tell the server, hey, we are actually passing JSON data here. So please, just that you know how to deserialize that data server side. So I'm going to say content type application.json. That's really easy. That will then attach a header for us. And we can say the body is just our POST request. And it will automatically be parsed to JSON and attached to this request. Then we get some more errors here because we return an empty list. Instead here we want to return null in that case. Here, and here. Like that. And then all the errors are actually gone. Now, one thing that's really missing is we need an instance of this HTTP client. So we need to create that where we just define some basic information and some basic features this client should have. And where do we do that? Well, we can do it directly in our post service, that we create that we just have a create function in a companion object, just similar to just a factory pattern. In case you use dependency injection, which I strongly suggest you in a real project, then I would maybe still use this factory array of instantiating that, but then you of course provide the corresponding the corresponding instance in your module, in your Dagger module or so, whatever you use. For this simple tutorial, I will create a function called create, which will return such a post service. And here we can just say return post service implementation, because that is what we want to use for our production app. And we need to pass a client. For this client, we need to say HTTP client, and this now takes the so-called engine. So actually, yeah, it is kind of what drives this client, because there are different engines for different platforms. We're on Android, and that is also why we included this client Android dependency here. That comes with this Android client, so that this actually works on Android. Here we just pass Android, this from Ktor-Client engine Android. Press enter, import that, and then we can configure that client in this Lambda block. Now in this Lambda block, we can install so-called features. If you know Ktor server-side, you will know these features. So what can a feature, for example, be? A feature could be logging, that we log network requests. A feature could be JSON serialization. A feature could be authentication. All that stuff is a feature in Ktor, and it's really cool because we just need to include a dependency that will come with a feature, and we just say install logging. Boom, and we have logging functionality. It's really that easy. If you then want to configure that feature, you can also do that in another Lambda block. Like we could set the log level, for example, to log level all. So just we log everything, just to show you how you could configure that. That's not a necessary feature because it's just for logging. It's a helpful feature, but one that is necessary here for us is actually the Kotlin serialization plugin, that we apply that it automatically parses this post request, for example, to JSON and attaches it to the body, and that it also automatically parses the response here from this GET request to a list of post response. So we want to install the JSON feature, and here we can again just configure that. We want to assign a serializer, so that feature just says, okay, we want to be able to serialize JSON data and deserialize that. But we don't specify yet how we want to do that, with which plugin, with which dependency or library. So we could use JSON here, we could use Marshy, but what we use is actually the Kotlin X serializer. So we can say serializer is equal to new Kotlin X serializer, which you could also further configure here, which we don't need. And that's all we did. That's how we create our instance of a Ktor-Client. Then the rest will be the main activity, just that we make the request and populate our UI with that. So in here, just an empty compose project. I'll just put my client in here. Don't do that in a production app. You want to use dependency injection in the view model. Private client would actually just be equal to post service. Come on, post service create. Then to make the network request, I will use the produce state function. So we can get the post list here by using produce state. We can define an initial value and a producer. If you watch my Compose Basics playlist, you will know this function. We just define an initial value that will immediately emit here as a state. So that will just be an empty list of a list of post, actually, post response. And the producer will be a function, a coroutine scope actually, in which we can call coroutines, so suspend functions, and actually assign new values to the state when we get the results of these functions. So we can say value is equal to post service, how did I call it, client? Yeah, let's call it post service. It's not a client, or just service. So we can say service get posts, and when we have the result, we assign that to the value, so to the value of that state. That will change and it will recompose our UI. I won't implement any mechanisms here to post something. I still wanted to show you how you can write a post function with Ktor-Client. I mean, this one here. I've tried it out. Trust me, it works. You can also try that and see the logs. Or you just, really implement a real app and try that out there. Just for that here, we want to just use a lazy column to show the content. Here, we want to have an items block using this overload here, which will be post.value. And in here, what do we want to do? We want to have a column. We can give it a little modifier dot fill max width, and just some padding of, let's say, 16 dp, import dp, and then just having two texts here to display the title and body. So text it.title, font size, let's set that to 20 sp for the title. Having a little bit of space with, let's say, height of 4 dp. And then we are going to have another text for it.body. and the size set to, let's say, 14sp. And that's it. The only thing that's missing is the internet permission. So in our manifest, we want to add that here. Uses permission internet. And there we go. We can actually now launch our app and try that out. So let's see, it's installing. And yeah, there we go. Our result from our API is just a list of these sample posts. So it seems like everything worked. If we take a look in our console, then we will see the logging stuff. Here you can see we get the whole response because we set the log level to all. And if we scroll a little bit up, then here we also see the other data, so like headers that were attached. What else, like the URLs here, what type of request it is, the response type. It's very helpful if you have an issue with your API and your responses and you just want to debug that. I would always throw in that logging feature and just remove it before the production build. So that is it for this video. So I personally will probably use this more often in future, also for non-KMM projects, just to have that in mind that eventually I will adapt this app to KMM in future. So I will try to design apps in a Kotlin only way as much as possible, because yeah, that way I stay flexible, and when I want to make that multi-platform, then I can do that and I don't need to rewrite my whole app. I hope you liked it. If so, then you will also definitely like my free email newsletter. I will send you regular Kotlin, Android and architectural advice right into your inbox. So to subscribe to that for free, you can check the link down below. And I wish you an excellent day. See you in the next video. Bye bye.